When stories about the chief designer of the WS-19 appeared one after another in public publications in March 2026, and the official catalog for the Singapore Airshow clearly stated that the engine's thrust per unit reached 11.8 tons. Were we witnessing the birth of a new benchmark in the medium thrust engine sector? The answer to this question may lie within the intricate web of details woven from a recent series of public reports and airshow information. At the Singapore Airshow in February 2026, AVIC placed a full-scale model of the J35 at the center of its booth, and a single line of English-language performance specifications regarding the engine in the publicly distributed program booklet quickly drew intense attention from the outside world. According to the brochure, the J35's target power configuration consists of two WS-19 series engines, with each engine's thrust explicitly listed as 25,000 to 26,000 pounds. Converted to metric units, this places the figures within the range of 11.3 to 11.8 metric tons, with the upper limit of 11.8 metric tons being particularly noteworthy. To understand the significance of this figure, it must be compared within the context of advanced medium thrust engines currently in service worldwide. The J200 engine used in Europe's Eurofighter Typhoon has long been regarded as the performance benchmark in the medium thrust category, with a maximum afterburner thrust of approximately 9.1 metric tons. The F414G400 engine, widely used in the USF, a 18E/F Super Hornet carrier-based fighter, has a maximum thrust of around 10 metric tons. Even the enhanced F414EPE model subsequently introduced by General Electric with its claimed thrust of 11.9 metric tons, remains largely in the technical validation phase, and has not yet entered large-scale production. This implies that if the WS-19's 11.8-ton thrust figure is ultimately verified, it will enable the J35 series fighters, equipped with two such engines, to achieve a combined twin-engine thrust exceeding 23 tons, a figure that already surpasses the power levels of some early heavy fighters. More crucially, this official disclosure of performance metrics aligns closely with reports from March 2026 in domestic publications regarding the WS-19's chief designer. These publications mentioned an easily overlooked yet highly significant detail: the Roaring fighter jets are equipped with two new engine types. She oversaw the development of the phrase, "two new engine types," in this description, combined with online discussions regarding engine configurations for different variants of the J35 series, has been widely interpreted to suggest that both the WS-21 and an early version of the WS-19 of May have simultaneously entered operational service. A widely held view is that the J35's powerplant configuration adopts a clear and pragmatic, staged progression strategy. As a brand new medium-sized stealth platform, the J35 utilized the WS-21 engine, developed from mature technologies, during its test flight and initial mass production phases. This engine is speculated by observers to be a significantly upgraded version of the WS-13 series, with a maximum thrust ranging from 9.5 to 10 metric tons. Its stable and reliable performance is sufficient to support the aircraft's design certification, pilot training, and the formation of early tactical squadrons. This approach mirrors the process followed by the J-20 fighter, which initially used Russian-made L-31F or WS-10C engines as a transitional measure, before eventually switching to its target engine, the WS-15. Meanwhile, the WS-19 series, particularly the WS-19, as mentioned in the Singapore Airshow brochure, plays the role of the target powerplant. Its 11.8-ton thrust will provide the J35 with a transformative performance boost. Greater thrust directly translates to a higher thrust-to-weight ratio, meaning the fighter will reach a new level in takeoff, climb, instantaneous turning, and the crucial capability of supersonic cruise. For carrier-based aircraft, powerful engine thrust provides greater safety margins during catapult launches and ensures sufficient remaining thrust to handle emergencies during go-arounds following a failed landing. At the same time, higher fuel efficiency and greater total thrust will directly translate into a significant increase in combat radius and endurance. When evaluating the performance of the WS-19, observers often compare it to the latest upgraded version of the US F414 series, which serves as further evidence that China has already reached world-class standards in the field of medium-thrust turbofan engines. However, maximum thrust figures alone cannot fully define the quality of an aircraft engine. Service life, reliability, full life cycle maintenance costs, fuel consumption characteristics, and stability under real-world operating conditions are equally critical indicators for assessing its overall performance. The reason the F414 series has become the power plant of choice for numerous Western mainstay fighter jets is not only due to its balanced performance but, more importantly, its exceptionally high reliability and mature, well-established support system, built up over decades of service. Therefore, for the WS-19, the thrust figures announced at the Singapore Airshow serve more as a highly significant entry ticket, proving that it has already attained the capability to compete with top-tier international rivals in core performance metrics. The next critical step lies in whether it can maintain consistent quality during mass production and, once in service, demonstrate reliability, durability, and maintainability that match its thrust figures. Judging from the recent public reports featuring the chief designer's account and the implied simultaneous deployment of two types of engines, the WS-19's engineering and development phase has clearly achieved a decisive breakthrough and is steadily progressing toward the design finalization and small batch production stages. Another noteworthy perspective is the potential for differentiated engine configurations across the various versions of the J-35 series. There has long been speculation online that the Air Force variant, the J-35A, and the Navy carrier-based variant, the J-35, may not share exactly the same engine configuration. Given the high salt, high humidity, and highly corrosive marine environment faced by carrier-based aircraft, as well as the immense impact loads resulting from catapult launches and arrested landings, the naval variant imposes even more stringent requirements on the engine's corrosion resistance, structural strength, and instantaneous thrust response. Therefore, a reasonable assumption is that the WS-21 may be used more extensively in the early production runs of the Air Force variant and in export models to achieve the goals of rapid combat readiness and cost control. Whereas the WS-19, which has undergone thorough validation and offers superior performance, may be prioritized for the naval carrier-based variant, becoming the final choice for the complete J-35 to ensure its dominance in future air-sea engagements. Looking back at the development of China's aero engine industry, from early reverse engineering to independent R&D, and from addressing basic needs to pursuing world-class standards, every step has been accompanied by breakthroughs in technical challenges and the consolidation of industrial foundations. The story of the WS-19 is not merely the success of a single model. It serves as a mirror reflecting the systematic progress achieved by China's entire aero engine industry in fields such as materials science, thermal engineering, digital design, and precision machining. Behind the seemingly simple specifications of the WS-19, listed in the Airshow catalog lie over a decade of sustained investment and technical research. The cumulative macro-level achievements resulting from countless engineers' incremental breakthroughs at the microscopic level, in areas such as blade cooling design, single crystal high-temperature alloys, and ceramic matrix composites. The fact that the story of the WS-19's chief designer was detailed in a public report in March 2026 sends a strong signal. The key challenges in the development of this highly anticipated engine have been overcome, and its technical status is nearing maturity. It is no longer a project confined to laboratories or test benches, but is poised to become the reliable power that will enable China's new generation of stealth fighters to soar through the skies. When the J-35 series fighter jets appear on aircraft carrier decks, or at Air Force bases equipped with this more powerful heart, it will signify not only the entry into service of a new fighter model, but also a significant leap forward for a nation's aerospace industry in the field of core propulsion systems. Looking ahead, as the WS-19 matures and is installed in production batches, the full performance potential of the J-35 series will be truly unleashed. At that time, whether forming a high-low mix with the heavy stealth fighter J-20 or serving as the aerial sword of an aircraft carrier strike group, the J-35 will, with its outstanding stealth design, advanced avionics, and powerful propulsion, constitute a key link in the air power system. In the broader global defense market, a top-performing, mature, and reliable Chinese heart will also serve as another solid calling card for China's high-end equipment as it goes global, offering a truly competitive option, free of strings attached, to nations eager to acquire advanced air power, but constrained by specific political conditions.